Suppose we have the standard equation of a hyperbola with center 0, 0 and foci on the x-axis. In this video, we will examine the geometric meaning of a and b appearing in this equation. We know from the discussion of general properties of the hyperbola, then the value of a is the distance between the center and a vertex, and therefore the number below x squared, a squared, determines the vertices. Vertices are plus or minus square root of a squared and comma 0, which is plus or minus a comma 0. Notice also from the graph that the vertices are x-intercepts of the graph, and therefore the number below x squared in this equation determines x-intercepts. Now what about the value of b? We can see that the graph does not have y-intercepts, and you can ask what is the algebraic reason for not having y-intercepts. So let's try to evaluate the y-intercepts. To do that, we'll have to set x equals 0 in the equation and solve the equation for y. If we do that, we'll end up with the equation negative y squared over b squared is equal 1, which will give me y squared is equal negative b squared. And this equation has no solution. So indeed, our graph does not have y-intercepts. This equation has no solution because on the left-hand side we have a number that is always positive or possibly 0, while on the right-hand side we have a number that is always negative. Those two can never be equal. So we conclude that the minus sign in front of the term with the y prevents the graph from having the y-intercept. So to summarize the property, we can say that for the standard equation of the hyperbola with centered 0, 0 and the foci on the y-axis, the negative sign in front of the y term tells us that there is no y-intercepts, and the x-intercepts are determined by the number below the x squared. Does this mean that there is no relation between b and the graph of a hyperbola? And the answer is no. As it happens, a hyperbola has asymptotes, and the slopes of those asymptotes are determined by values of a and b that appear in the equation. The asymptotes of a hyperbola are discussed in the next video.